The abbreviation TIG stands for tungsten inert gas, where you use a tungsten electrode to strike an arc between the electrode and the workpiece. The TIG process is used where you need a high quality weld with no requirement for additional finishing. There is a minimum voltage at which electricity will flow in the gas. This voltage is called the ionization potential. This is the potential measured in volts at which the current will conduct between the electrode and workpiece through the gas. The voltage in the circuit must be above this potential to maintain the welding arc. When choosing the gas, it's important to consider the ionization potential. The most common gases are argon and helium. You can use mixes of argon and helium together, or you can add other gases such as hydrogen and nitrogen to the mix, dependent on the process you're using. The most common gas in use is argon. It's the cheapest inert gas. Argon's colourless and it has an ionizing potential of around 15.7 volts. Argon has a low thermal conductivity, which results in a more compact, high-density arc. The energy is more concentrated and is therefore confined to a narrow area. It has excellent arc stability and cleaning action at low amperages. Argon is produced as a byproduct from the production of oxygen. It can be formed in a gaseous or liquid state in either specially constructed vessels or cylinders. Helium has an ionization potential of 24.5. It has a high thermal conductivity. As a result, the arc column expands, making the energy less concentrated and spreading over a wider area compared to argon. The more flared out the arc column, the more work surface area is being heated. The heat at the centre of the arc can move more readily downward toward the colder metal at the bottom of the workpiece. This results in a deeper penetrating arc. The gas flow rate you use in TIG welding should be sufficient to cover the molten welding pool, otherwise you'll have problems with defects in the weld. A typical flow rates for the gas are between 8 and 12 litres per minute. If you're using helium, it could be double that amount. The normal modern cylinder now takes up to 300 bar pressure, and we use a regulator and flow meter to bring that down from 300 bar to a workable outlet pressure.